In this video, we'll be learning how to use a calculator to evaluate expressions which contain complex numbers. It is very likely that you have a calculator of this model FX981 series for Casio. I do not have the emulator for this calculator, but I have an emulator available from the Casio website, class-based emulator. It is downloadable from the Casio website. You can download it from here. It contains pretty much the same functions as contained in this calculator. I'll be evaluating expressions in here, and I'll be referring to what buttons to press for this model in this image. So let's take an example of some equation, some complex numbers, such as we have 2 plus j3 minus 4 angle 50 degrees, and let's say we have in the denominator we have 5 plus j6 plus 3 minus j7, and let's take another number plus 3 angle 45 degrees. Let's say you have this expression, you need to evaluate it. The first thing you need to consider, or you need to make sure, is that here the calculator has to be in degree mode, because the angles given in the complex numbers which we use to represent phasors, the angles are always given in degrees. So make sure the calculator is in degrees here, unlike in this image of here the calculator is given in radians. So make sure that you press shift and then press setup and then go to degrees in this calculator. So this thing is already in degrees, so I do not need to shift it there. So let's try evaluating this expression. So I need to press 2 plus j3. So for that, I need to do is I have to go to menu or setup in this here, and here in this calculator you need to select the mode or setup button. So in there you have to press 2 because it contains the complex symbol for iota and the angle sign. Iota is J in electrical engineering, so I'm going to press this thing, and then I need to press 2, or just press 2 here in this calculator. You need to, once you select the mode, then you go, just it will say 1 for computation and the normal computation mode, and 2 for complex. So select 2 for complex in this calculator. So this thing is in complex mode. It contains I here. I think it also displays the symbol I here. So I need to enter this expression. The first thing you need to consider is that if we have a minus sign next to a complex number which is represented in polar form, so this in polar form, this 4 angle 50 degrees, I'm talking about this number here, this has, this is the magnitude. The magnitude is never negative. So if you are going to press right next to it minus sign, always use brackets. So I'm going to use brackets here. I'm going to demonstrate what's going to happen if you write, let's say if I write minus 4 and then I have to select this thing, so this angle sign, I'm going to press shift and angle, and then if I press 50, and this thing is already in degrees, so I do not need to put the degree sign here. So if I press equals to, it says it's math error. So if I press cancel and I write minus, and then I use the bracket for shift angle 50 degrees and then close the bracket, it says this thing is equal to minus 2.57, and if you press the right button, it will say this thing is the y part, the y-axis part, and this thing is in the x, the real part. So if you press the single line to double line, it says this thing minus 2.57 minus 3.064 I. If you want to represent this number, instead of in the rectangular form, you want to convert it into polar form. So in this calculator, which you might have with you, in this calculator you need to press shift, and then you need to press complex. So it will display the menu whether you want to display whatever the result is in a plus bi or or r angle theta. So whatever you select the option, it will display accordingly. So coming back to here, I want to represent this result, in polar form. This thing is given in rectangular form. So I'm going to press options here, and it says the argument, the conjugate, the real part, and the imaginary part. I mean that would be the menu which you would have been displayed if you press shift and then press 2 here in this calculator. So I'm going to press 1 here, so it's going to represent, it's going to convert the answer which was given in the rectangular form to polar form. I press equals to, it says 4 angle minus 130. So I mean if you are if you are appending a minus sign to a polar number, you are actually subtracting 180 degrees from the angle, because here these numbers, these complex numbers, I mean this thing is 4 angle 50 is actually 4 e to the power j 50 degrees. There is another thing which I'm going to discuss in some other video, that it has also j omega t written right next to it, but we usually do not write it because this is understood to be present right next to each complex number. So I'm not going to write that. We are only concerned with this part only. So 4 e to the power j50 is written as 4 e to the power 50 degrees. I mean this thing and this thing are exactly the same thing. So if you are representing this thing in polar form, you can use that, or you can convert it into rectangular form. Let's try doing that. If I press 4 sorry, not I, shift and this thing 50 degrees, so this thing is given in rectangular form here, because here the setup, if you press shift and then press go to setup, it will say if it will say input output angle unit should be in degrees if you are evaluating phasors. It could be in radians, it could be in gradient. And if you go to the complex part, the 2, if I press 2, it will say that what is the default option you want to display the results in. If I press 2 here, the answer would always be given in polar form. Okay, so if I write 2 plus 3i, so this thing would always be given in the polar form. This is the magnitude, and this is the angle. Another thing we need to consider is, let's say if I want to write this number 2 plus j3. So if I want, just I'm talking about this number. So if I write 2 plus j3, j is actually iota, because the symbol for current in electrical engineering is I. Therefore we do not use I for the iota, we use j. I mean that's customary for to say that j means exactly I. So if I want to write 2 plus j3 in the calculator, I'm going to write 2 plus, if I write this 2 plus i3, it's going to give the syntax error. So what I need to do is that instead of writing 2 plus j3, I'm going to write 2 plus j, so 2 plus 3i. So that's the correct form I need to, and this is going to display the output in the polar form. Or if you want to convert this thing into rectangular form, go to option and go to 2 here. It's going to convert the answer into rectangular form. It's going to say 2 plus 3i as we did before. In this calculator which you might have, you need to press shift and then press complex and then convert the number into either rectangular form or into polar form. If you want to convert if you want to change the default setting, go to shift and then setup and then select complex, and then select the correct or select the appropriate output for your answers. Usually I prefer the outputs to be given in the polar form. The reason is that we can easily convert. Let's say if I have this number, let's say if I have 3 angle 50 degrees, and let's say that might have been some voltage. We are going to evaluate this expression in a moment. So if I write 3 angle 50 degrees, that is in voltage, and let's say omega is given in radians of, let's say 1000 radians per second. So I can easily convert this thing using the formula Vm cos omega t plus theta. I mean this is the phasor representation, this is the time domain representation. If I convert from this to this, I mean from phasor domain to time domain, or frequency, and this thing is the frequency domain and this is time domain, I can write the maximum value 3, which is given here, the magnitude, and I write cos, and omega is 1000, t, and 50 degrees will go from here to here, so I'm going to write 50 degrees. So if I have the answers given in polar form, it's actually much simpler to convert. I mean, if you have the answers in rectangular form, you have to convert it into polar form to convert or to transform the phasor or the complex number representation of that phasor into a time domain quantity. So here let's try evaluating this expression. Keep in mind this is actually minus and we are subtracting the whole thing. And if you have some minus sign over, let's say if this is plus and this thing is actually, let's say, minus, so watch out whether you are subtracting the only the real part, and let's say we want to subtract the whole number or the whole complex number, use the brackets. If you have plus sign, you do not need to worry too much about it, but you have the minus sign, always use the brackets if you are subtracting the whole complex numbers. Okay, and if it's just a real part only, for some reason you can use without bracket, but if you are subtracting the whole complex number, because this thing would be minus 3 plus j7 if you multiply the minus sign. So I'm going to evaluate this expression in the calculator, and here let's this thing is in this thing is in complex mode because I changed the setup to I change the setup to r theta, so that's why it's now displaying the angular part. I mean, if this calculator is still in complex mode. Okay, so I'm going to write this thing is given in expression, so I'm going to write the numerator first, 2 plus 3i. Okay, 2 plus 3i. I'm not going to write 2 plus i3, reason I've explained it just a few moments ago. And then I'm going to subtract, but watch out, this thing is given in the magnitude, it cannot be negative, so you always use a bracket. So I'm going to use the 4, and for shift angle 50 degrees. Okay, so this thing already given in degrees, so I do not need to write a degree sign here. If you want to write, and if the calculator had been set up in radians, in this calculator, if you write this expression, you press shift and this number answer, it will display 1 for degree, 2 for radian, and 3 for gradient. If I select 1, it will display the degree symbol next to this, and even if the calculator had been in radians, it would evaluate this thing in degrees. But here the safe side is just write I mean, just set up the calculator in degrees. If I write 5 plus 6i, and I'm going to subtract this number 3 minus j7, so if I write 3, I mean the original example was given in plus, and just to emphasize the brackets, I've changed it to minus, so just take it as minus 3 minus 7i. Okay, and I'm going to add 3 shift angle 45 degrees. If I press equals to, it says the answer is 0.0366 angle 111.65 degrees. If I want to convert this thing into rectangular form, I just select option and I go down and I select 2, so it says the answer is given in the rectangular form, minus 0.0135 plus j 0.0340. Let's and after doing these practice, I want you to go to your textbook, which was posted to the class folder a long time ago, and you have to take a look at the complex number appendix B. I mean, this is given in appendix B, and you have to go through this thing and say, I mean, this thing is, let me zoom in a little bit. I mean, this thing is exactly like this thing. I mean, these are the exponential form, and if you just write it there, I mean, just two ways to represent a complex number in polar form. This thing is given in the rectangular form. So let's take an example of okay, here it says we need to evaluate this thing j 3.3 minus j4, and we have a star sign next to it. Whenever we see a star next to a complex number, it means it is the conjugate of that complex number. Okay, by conjugate we mean that if it's 3 minus j4 and you put a conjugate to it, that means it will become j3 plus j4. So let's try doing that in the calculator. So I'm going to write I, and it's just an expression, right? It's a fraction actually. So I'm going to write I, and I'm going to open a bracket, and since this thing is given in the conjugate form, therefore I'm going to write, instead of writing 3 minus j4, I'm going to write 3 plus 4I, and then in the denominator I'm going to press, and then I'm going to write minus 1 plus j6 minus 1 plus 6I, and here I'm going to write 2 plus I, and this thing is given in the square. So let's say the answer would be a 0.164 angle minus 9.46. If you want to display this thing into the rectangular form, so you need to go for this thing, and then it has in the rectangular form. In this calculator, for angulars, I mean, if the calculator is already in complex mode, so you, for the angle, you don't need to use the shift key. Just press this thing and the angle sign will display right next to the magnitude. If you write 25 angle 30 degrees, so I press 25, then press this button, then write 30, calculator has to be in degrees, and it will just take it. I do not need to press the shift button and do this. Okay, and similarly, if I want to display the result in whatever format I want, I just press shift and then I press this button. It will display the menu to select whatever the output form you want.